Hello guys, again good morning. So this is a lecture on the minimum design loads, focusing on gravity and vertical loads first. And our reference here is the NSCP C101-15, which is the National Structural Code of the Philippines. So for the dead loads, we may refer to section 204, and this is defined as those loads which consist of the weight of all materials of construction. Okay, so these are the materials used basically uh, for construction purpose, and they are incorporated into the building or any other structure, like bridges, etc., including but not limited to this list. Okay, so these are enumerated here, and you will notice that these are structural parts which are very familiar to you for now. So we have the walls, the roof, the ceiling, the stairway, the partition, the finishes, the cladding, the architectural components, the structural components, the service equipments, etc. Okay. So to differentiate dead loads to other loads, just try to look into the note below that the dead loads are simply the items that are assumed to be permanently. Okay, so this is the keyword for that. They are assumed to be permanently attached to the building in a specific location. Okay, so if we know the location specifically of a component which are enumerated here, and they are more or less permanently attached to it, then we can say that this is a dead load. So the word dead here simply refers that there is no movement, okay, of the load from one specific location to the other. So when you say movement, the loads does not uh, appear in one location now, and after an hour it goes somewhere else. Okay, so that's the definition of being permanently attached. No? So this is a technical description or technical definition to make the dead loads different from live loads. So the actual dead loads or the actual weights of these materials for the dead load should be used uh, for that purpose. So we need the actual weight, okay? But since sometimes we cannot just get the value of that weight, and in terms of exactness, we may refer to some tables provided by the code to use as minimum values in the absence of this information. Okay, so it shall be permitted to use a minimum value uh, presented on tables 204-1. Okay, so this is 204-1 and 204-2. Okay, so that's how you do it. If you cannot go into the determination of the actual weights because of some difficulty, you may opt to use the minimum value. as presented in this code. And for the built-in, the partition or the built-in partition, notice that there is a mark here, number 1. So take note that the partition we are talking here uh, when actually subjected to some changes in location, or there is a likelihood of uh, movement, no? Sometimes we cannot predict if the partitions are will not move for a very long period of time, no? Then we can assume it to be a movable partition. And in that case, since the location is not fixed, so we opt to consider it in terms of a UDL, no? A uniformly distributed floor load on the building, equivalent to 1 kilopascal. Of course, this 1 kilopascal is only a minimum assumption, and you can change it depending on the type of partition you are uh, expecting to be placed, but the location is not specified. Okay, so this is just notes for you to be able to interpret the computation for dead loads quite fairly well, because these are very important consideration in your analysis and design. So let's take a look. Let's just take a glance of what the tables 204.1 and 204.2 gives us here. So for table 204.1, you will see here some suggested uh, unit weight. Okay, so you have here a unit weight of the material, and this unit weight are computed in terms of the different types of possible materials you will be needing in construction. Okay, so how are you going to use the unit weight? So you first take a look at the geometry of the dead load material. Okay, if you can look at the geometry, let's say it's something like a cubical dead load like this. All you have to do is get the volume. You just get the volume of this. Okay, and then multiply it by the unit weight. Uh, you get the total weight. Okay. Okay, and if you know the specific location as defined by the dead load definition above, okay, so specifically you know that this is located at a certain point P here. Of course, dead loads are gravity loads, so you may represent it simply by a weight towards a certain member being designed. Okay, so this is now the total weight. It can be a concentrated load, or it can also be represented by a uniform load, no? So it depends upon how you would see the geometry of the material. Okay, so there are a lot of uh, material listed here for reference, so we can actually come up with of with a variety, no, of dead loads we can think of based on the material description. And of course, the very useful materials here are the masonry materials here. So you can see masonry, stone, bricks, concrete, grout, rubble stone. Also, you have here material such as particle board and plywood in terms of density or unit weight. Okay, if you are using glass, so there's a glass material here, gravel, gypsum material, etc. Okay, so you will be using this table more if the volume of the material based on its geometry is given. Okay, for table 204-2, the unit used for this minimum design load is kilopascal, which simply implies that we can use this whenever a flat surface, no, a flat uh, geometry or surface is uh, considered on the application of your dead load. Example, if the ceiling is a flat surface, so if you know the area of the ceiling, okay, so the area of the ceiling, so you can simply multiply the pressure, okay, so this is a pressure in terms of kilopascal multiplied by the area, you get the force, okay. So if you know the area and the pressure P, you get the total force here. So this is simply equal to P times A. So all flat surfaces in terms of the geometrical representation of the surface upon which the load is applied, we will be using table 204-2 as reference. So covering of roof, so we know that roof, okay, requires also a surface area like this. So if the roof is defined in a manner, okay, like this, then this is again a flat surface area upon which if you know the unit weight times the area, again this is simply a force P times A. Of course, the distribution later may be assumed to be concentrated or uniformly distributed on a projection of the area. Okay, so ceilings, coverings, floor fill, floor finishes, frame walls, concrete masonry, they are all represented to be applied to flat surfaces, frame partitions, etc. So these are all in pressure units, kilopascal. So all you have to do is to determine the area of in which the material is placed and then multiply it, you get the force. And if you want to convert it into a projection area, you again divide it by the area of projection, you get the uniform pressure applied on the area. So this is how the procedure works when you are computing loads, and also the softwares are using the same fundamental principle in their computation. Okay, so that's it for the dead loads. The dead loads are not difficult to compute, but they are very important in the aspect of analysis because they exist. They are always there to make your member behave in the way it should behave. So don't forget to apply and compute the dead loads very accurately, because they mean a lot to the result of the analysis. So thank you very much for listening. We'll continue on the live load computation based on the NSCP on the next video.